structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAS Structi has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IAS Structi is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAS Structi has collaboration with various international professional like-minded associations and institutions. IAS Structi's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAS Structi endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAS Structi is actively engaged in organizing several continuing professional development CPD courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAS Structi's activities are widely appreciated and known for quality technical contents. IAS Structi is also actively engaged in publishing its quarterly journal Structural Engineering Digest SED, code commentaries, professional guidelines and a monthly newsletter. IAS Structi's publications are becoming popular with time. IAS Structi has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAS Structi started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAS Structi is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAS Structi has its student chapters in several leading engineering institutions as well. Membership of IAS Structi is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAS Structi is available on its website www.iastructi.co.in.
Yeah, Dhawan sir.
My voice is audible?
Yes, sir. Yes.
My voice is audible?
Yes, sir.
Yes, yes, sir.
My voice is audible?
Yes, yes, sir. Yes, sir. Please.
Yes, sir. Hello. Yeah, Dhawan, sir. Yes, sir. I think there is some internet issues.
My voice is audible? Sorry.
Yes, sir. Yes, sir. Yes, sir. Audible.
Welcome to the participants. We are grateful to our speaker, Dr. Ajay Charosia, for talking on the very important topic and out of his busy schedule. Regarding Dr. Charosia, he is the chief scientist and head of structural engineering and 3D concrete printing group at CSIR, Central Building Research Institute, Roorkee. He did his PhD in structural engineering from Indian Institute of Technology. His area of interest encompasses precast buildings, structural dynamics, structural health monitoring, experimental investigation of buildings, earthquake resistant design, construction and retrofit confined masonry, seismic vulnerability, post-earthquake damage assessment, precast building, 3D concrete printing, numerical analysis, historical construction, etc. He is well-organized person with strong technical expertise, leadership, and problem-solving ability, result-oriented approach, and moreover, his R&D in structural engineering is his passion, focusing on technological solution to the nation and society at large. Now, regarding topic synopsis of the webinar, the topic is structural health monitoring of buildings using Wavelet transform approach. As we all know that buildings and building components undergo deterioration during their service life. Therefore, structural health monitoring in building plays a significant role in the safety and sustainability aspects, thus minimizing the sudden failure and maintenance costs. For the last 3 decades, there has been an increase of real-time monitoring of building for health assessment with technology advancement, new techniques like short-time Fourier transform, wavelet transform, Hilbert Hurang transform, etc. found their way in signal processing and health monitoring application. Wavelets are an excellent tool to analyze non-stationary signals and offer an advantage of keeping intact the time dependency of spectral information of signal. This presentation establishes the variation in model characteristics with change in mass or stiffness of building structures analytically. Now I pass on the to Dr. Chirosia, please, Kali.
Yeah.
Dr. Chirosia, please, Kali.
Yeah. Yeah. Is my slides visible?
Yes, sir.
And am I audible also, no?
Yes, sir. Yes.
Now the slides are rolling down.
Yes, sir.
Okay, thank you. Thank you. Can I start my presentation now, sir?
Yes.
Okay. Thank you, Dhaval sir, for the very kind and nice introduction. And thank you, my dear friends, participants, for sparing your valuable time and showing your interest in this subject and attending the event. I'm very sincerely by heart, I would like to thank ISTRUT for giving me an opportunity to discuss a very pertinent subject, that is on structural health monitoring of buildings using Wavelet transform approach. So basically, and to begin with this particular presentation, so basically, in the recent past, there is a lot of infrastructural growth. And when you talk about any infrastructure or habitat, so that will involve your buildings, bridges, roads, tall buildings, and whatnot. So these buildings are getting deteriorated over the time because of different aspects. So how to evolve a methodology which is rapid, effective, and which will alert the client from time to time before going into detailed retrofitting or some preventive measures. So for that purpose, that particular subject is dealt in the structural health monitoring. So outline of my presentation is introduction to the subject and define what is the structural health monitoring, then methodology. Then I would like to mention the sensor technology, what are the testing systems categories, then structural health monitoring system design. Then I will discuss that thing with certain uh, case studies in entire this particular episode. I think analysis of the collection of the data and analysis of the data is very, very important. So there are different techniques for that. And I will discuss the most efficient technique which is applicable to this particular buildings as such or infrastructure as such, and what is the future of the SHM. And based on our past experiences, important conclusions, what I would like to mention if you want to really deploy this particular subject as a profession. So with this, when you talk about any infrastructure which includes roads, sewer lines, highways, or buildings, and so on and so forth, so they have been constructed, and if whether it is of RCC, steel, or whatever material, so this material is having inherent characteristics. They are getting deteriorated because of several reasons, and they in sometimes they are getting neglected, no maintenance, and these are the different reasons which basically putting our global infrastructure into crisis. And when you see what are these factors which are adversely affecting on our infrastructure, is primarily basically the degradation of the structure of the buildings or infrastructure because of weathering effect and aging. So, and unfortunately, when once the structure is constructed, or then it is getting used by everyone, but maintenance and its attention from its life extension point of view or its maintenance point of view, least importance is given. And as a consequence, there are problems which becomes apparent only when the structures are getting dire in need of repair. So we invest nothing or very least important aspect when you talk about the degradation is concerned. And as a result, if you don't invest in maintenance of the structure, it will cost you manifold when it is showing some kind of deterioration or failures. Second cause of concern of structural degradation is due to the corrosion of, because generally the structural elements are composites comprised of concrete and steel is getting corroded because of several reasons, and as a result, there will be a volumetric expansion of steel, and that puts the lateral thrust on the cover concrete, and as a result, you see the cracks on the concrete surface. So that is again putting our structure into a dangerous categories, and as a result, there is a reduction in strength, serviceability, and resulting in need for repair and replacement of that particular structural element on an urgent basis. Another cause of deterioration could be due to the increase in loads, because over the time our loading is increased, and the structure might not be designed that particular loading, and because of overloading also one of the cause of concern that we need to pay attention on understanding the structural behavior and do certain structural intervention to cater the need of in terms of loading. Another factor which affects the structural performance in terms of life and serviceability is the aging. So various detrimental effects on structural performance, both on safety and serviceability, also calls for repair, rehabilitation, strengthening, and replacement of the structures. And as a result, when you talk about retrofitting domain, there are vast number of advanced materials, technologies. But before going to retrofitting, one should know what are the different techniques which will alert me time to time, so that the structure, before getting deteriorated, it will give me a warning at initial stage itself, so that it will whatever the defects may be, that can be attended on urgent basis at the beginning itself, so that the cost of construction or cost of retrofitting or repair will not be much, and the structural life will also be safe. And for that purpose, there is a technique that is called as the structural health monitoring, and there are a lot of advancements which are happening in this particular domain, as well as it is happening in materials and other domains of the civil engineering. So exactly now it is very common or frequently asked question, what is the SHM, that is structural health monitoring, which is nothing but assessing the in-service performance of the structure using variety of measures techniques. And let us adopt a smart approach, and that is through certain instrumentation of a structure in a systematic fashion. So now the SHM is becoming popular over the period because of few reasons. Maybe the increase in need for monitoring. In this, there is a need to monitor the structure, design the structure first of all, and then monitor it by proper instrumentation. And when I compare the structure with the dynamic properties of the structure with the benchmarking, and there will be, due to the deterioration, there will be change in the dynamic properties, particularly the fundamental frequencies, I should say, mode shapes, damping, and all and stiffness. And if we focus on what is the change happening in these dynamic properties or dynamic characteristics of the structures, I think we will be and once you understand that is the way out to address the longevity of the structural systems. Further, the reason of popularization of this particular system is because of the advanced knowledge, advanced development in sensor technology, data acquisition and transmission or communication systems, and handling the data. So these are the innovations which making you this particular techniques very popular, which basically tremendously it will save the maintenance cost and inspection time also. In conventional, if you talk about, if you want to monitor the structure, traditionally we used to do the non-destructive testing, which is again the sometimes qualitative or quantitative, which has to be done on the on a selective basis on certain elements, and there are different techniques, and it involves a lot of uh, resources. But unfortunately, we take a call on NDT, non-destructive testing, only and only when we see certain kind of danger or distress in the structural system. Alternatively, with the advancement of the knowledge or technologies or sensors, particularly the embedded or surface mounted sensors, if we can instrument this particular building at initial, after the construction itself, or during it, whenever you feel like, and if we monitor the data, whatever recorded from time to time, and the change in the data will reflect you that yes, something is the structure is misbehaving, and from that particular data you have to arrive at which is the element which is creating problem, and instead of focusing on entire structure or building system, you have to pay your attention in strengthening, retrofitting of that particular structural element. So you don't have to do the global retrofitting, but you have to find out the local element, and that local element is need to be retrofitted, so it consumes less time also and investments as well. So basically the objective of structural health monitoring is from the structural safety, strength, integrity, and performance considerations. And the as a simple analogy of SHM with our human body is when you compare yourself with the our body. So you, whenever certain issues are happening to your body, you approach to doctor. He will monitor the patient. He uses certain equipments to check your health based on your problems, and he prescribes certain medicines or corrective measures. In the similar fashion, or in contrast, in SHM, an engineer basically instrument the building. He will monitor the condition of the building using instrumentation, different sensors, and he will capture the data, and through the data monitoring, he will come to know the malfunctioning of the data, if at all it is happening because of structural distress. So this is and to do this particular exercise, you have suppose this is the building, you have in the different buildings, you have to first of all see the priorities, which are the important structural element systems, and those instruments, those locations should be instrumented by different sensors. Again, that those sensors depends upon the characteristics which you are interested in, and any change in the properties will be captured and communicated to the data logger. So it is similar to your human nervous systems. In the muscles, you have nerves. If something goes wrong to the muscle, the nerves will communicate the malfunctioning on the muscle to the brain, and that's how you come to know something is misbehaving. In the similar fashion, your sensors are there at different parts of the structural systems. They capture the data continuous basis or periodically, but whenever it is crossing certain threshold, which you are fixing by different techniques and in your software, so it will give a warning to the engineer, and that particular warning will alert you that yes, my structure needs certain attention. So basically, the components involved in SHM is data acquisition system. So data acquisition, so placement of sensors, data acquisition of the data, communication of the data, intelligent processing of the data, because there is a huge number of data. So you have to take only important data, valuable to extract the meaningful result, and store the data which is meaningful only, instead of taking all the data and storing and consuming your spaces. So processing is also very, very important. And And as a result, you have to retrieve only the meaningful data, and that will basically direct you by means of different techniques the behavior of the structural systems. So for conducting the structural health monitoring studies, there are different ways or techniques by which the testing can be conducted. So such testing could be the static field test, dynamic field test, periodic monitoring, or continuous monitoring. Again, the choice of this test which you are adopting depends upon the importance of the building and problem which is concern for your system as such. So there are different sub tests are available. So let us discuss one by one. But before that, the classification of SHM system is done in 4 levels. Level 1 is basically calls for basically identification of damage. When you are able to successively identify the damage, what is the location of the damage? So detection and identification of the damage on structural element means location is more important. So that is level 2. Once you are succeeded in identification of the damage in the structure and its location and what is the extent of the damage, so that is classified as the level 3. And because of such severity, what is the consequences of the damage when your system alerts that kind of a intelligence? So that is that classifies under level 4. So worldwide now we are at level 3 when you are talking about the advancement of knowledge in our structural health monitoring systems as far as civil infrastructure is concerned. So whenever you are going level by level up and up, so increasing sophistication is needed. And definitely when sophistication is needed, you have to put a lot of efforts, and you will get a good output also. And with the minimum investment, you can maximize the performance or serviceability of your structural systems. So basically, as I mentioned, the advantage of SHM is basically due to the increase, it provides the increased understanding about the in situ characteristics of the structure. It will alert you in case of any kind of a damage in early stage. At that particular stage, you can take certain interventions to improve the structural strength and serviceability. And as a result, you need minimum time for structural retrofit or inspection. It will ultimately calls for a minimum maintenance cost and management strategies as well. And this, as a result, you will be able to deploy the effective deployment of your scaled resources can also be conducted. So, so when you are talking about having said the advantages of SHM, how beautifully I can put on my structural system is very, very challenging phenomena. And for that purpose, selection of appropriate methodology is very, very important, because in ideal SHM systems, it provides the information on demand about the structural health, and it provides the warning also if something goes wrong. So basically, when you talk about the structural health monitoring, it is a multidisciplinary subject. It involves the expertise or understanding in terms of materials, structural system, computers, communication, data collection, sensor technology, and its processing. So one has to be a civil engineer, and at the same time, it is a combination of civil and electronics. So sometimes this particular subject is called as a civitronics as well. So in short, to have a cursory view of SHM systems, so you have this, suppose this is a bridge, you are putting the sensors at different locations. The sensors could be a wired sensors or wireless sensors, and the sensors type also depends depending upon your parameters you are interested in, whether it is acceleration, displacement, or strains, corrosion. So based wind, temperature, humidity, all these are the parameters whatever the parameters you are interested in, appropriate sensors you need to place at critical locations. The data captured by the by these sensors is continuously sent to data acquisition systems. You are not supposed to capture entire data, so you have to do the intelligent processing there, and after that you have to filter the data, and only meaningful data need to be passed on to the offline office for its data analysis, processing, and storage purpose, and interpretation of data upon its retrieval for decision making in terms of structural health is concerned. So as I mentioned, data acquisition is very, very important. So for that purpose, you have to put different sensors. So that sensors could be strain for measurement of strains, deformations, acceleration, temperature, moisture level, acoustics, emission, loads, so on. And whenever you are dealing with the civil engineering, so your sensors should not be very sensitive, should be sensitive, but should be robust as well. And it should have a long-term and short-term. Again, the selection of the sensor depends upon whether you are focusing on the long or short-term monitoring. What is the structural type and location where you are monitoring? So these are the aspects one has to be dealt in. When once you finalize the sensors type, so installation of the sensors and placement of sensor is also very, very important. So based on your structural analysis, you need to identify the critical locations, and based on those locations you have to put the appropriate sensors. And for that purpose you need to, if it is a new structure or new building coming in, so you have to provide proper locations, sensor wiring for the sensors, conduits, junction boxes, and other accessories which are needed for structural monitoring purpose at the design stage itself. So this, as I mentioned, it is a civitronics, but yes, after placement of the sensors, again now you have to acquire the data. So data starts coming in. So whatever the data is coming, so that, as I mentioned, wired sensor or wirelessly you can transfer. There are certain advantages of wired sensors, but there are a lot of disadvantages of wired sensors because it is giving a very odd look if it is placed in the building. But wireless sensors, if you adopt, there are other limitations that wireless transmission is very difficult. Then it is a slow process. Sometimes there is a problem of interferences. So both the methods have certain merits and demerits, but you have to take appropriate decision, which, and based on the cost aspects as well, appropriate decision need to be taken that which kind of data acquisition systems and transmission systems you are going to adopt in your system. Now, another is you are getting the data continuously. Huge amount of data is there, but you are not supposed to analyze entire data. So you have to make a selection or choice which data is you are interested in. You extract only meaningful data from the data samples. So data acquisition, rate of acquisition of the data from the different sensors, and how many number of sensors I am putting in different structure, because and data sampling rates. What is the data sorting for on-site storage, and what is the how I will effectively analyze the data. That is very, very important aspect. And for that purpose, you have to take appropriate decisions and logical decisions also, because at one point of time you have to see the cost aspect as well as you have to see the computational efficiency also you have to work out. So for example, if you are talking discussing about the data acquisition algorithm, so you are continuously getting the data which is recorded only so in this only the values which are greater than particular thresholds you are interested in. So unnecessary data which is less than that particular threshold you are, it is of no interest to you. So such data can be overruled, and so that it will minimize your space requirement for storage purpose as well. Sometimes you are interested in to record only the significant changes which are happening. So you are not supposed to record entire data. So again, you have to fix, based on that particular objectives, you have to fix the threshold, and only the meaningful peaks and corresponding parameters need to be acquired or recorded. When you are talking about the data acquisition, so which data you are talking? So that data could be load, deformation. That data could be load, deformation, then strain, temperature, humidity, acoustic emission, and so on and so forth. So whenever you are focusing on load system, so for that purpose, you can deploy appropriate load cells at appropriate locations. For suppose, in case of a bridges, so you can provide load cells at different supporting at different supporting point, so that the whether you are to measure the loading aspects, which is important parameter might be for your structural system for measurement. So if you are interested in deformations, you have to measure, you have to place the LVDTs or strain gauge based transducers at appropriate location for measurement of deformations in the structural systems. Sometimes strains are also very much important. So intensity of deformation is captured in terms of strain. So magnitude and variation of the strains can be examined to evaluate the safety and integrity of the systems. So measured strain can be recorded by means of different structural innovations, that is by the fiber optic sensors, electric sensors, vibrating wire sensors, and so on. If you are interested to record the temperature, so you can make use of thermocouples or ITC sensors for measurement of the temperature. For acceleration measurements, which is very, very important from structural system point of view. So, which basically the loads created by, suppose, by some operation of some equipment or due to the seismic motions, earthquakes. If some vibration is happening, so if you are interested to record such vibrations or in terms of acceleration, so you have to place accelerometers or velocity sensors or displacement transducer. But accelerometers are generally adopted because of its shape, size, and very easy to capture the data. But yes, if you are looking into the very precise detail, precise acquisition of the acceleration parameter, displacement parameters because of earthquake, then you have to go for the displacement transducer and so on. But generally in civil structures, accelerometers are adopted for measurement of the acceleration parameter, for measuring the structural behaviors from seismic or any from dynamic characteristics point of view. Similarly, from the wind, you can deploy the anemometer. The acoustic emission point of view, you can provide the microphones at different locations, and nowadays video monitoring and other aspects are very prevalent, so that can also be deployed for continuous monitoring. Now, upon acquisition of the data, communication of the data is also one of the important element. So for that purpose, there are different alternative options or modes can be adopted, like telephone lines, internet, or wireless technology for transmission of the data from the data acquisition system, which is located at site, to the offsite locations for further processing and analysis. The intelligent processing is a prime domain. So for that purpose, which technique you are adopting for processing of the data, and technique of processing the data and arriving at and identification of the location and extent of the damage is also very important, very important. So there are different techniques. So I will discuss those techniques later. But to remove the unnecessary data, noise, thermal, or other unwanted effects captured in the data is very, very important for easier and faster and more accurate analysis purpose, and within minimum possible time. So data now when storage of the data is also very, very important. So you have, when you are doing proper filtration and valuation of the data. So your space requirement for the is also minimizes. So that is very, very important aspect. So based on the data storage and its analysis, diagnostic of the information about the structure again depends upon type of structure, type and location of the sensors you have deployed, and what is the motivation for the monitoring and structural response, which is under consideration for the structure. When storing the data for retrieval, you have to consider the significance of the data and the confidence in the analysis. So appropriate selection of the technique for the data analysis is also very much important. So now let us have a very quick look on the sensor technology. So fiber optic sensors are primarily adopted in civil engineering structural health monitoring system because it is a newer class of sensors emerging for infrastructure applications, and recent and ongoing developments are tremendous, and which is providing a very robust kind of sensor technology for civil engineering. So advantages of fiber optic sensors is that the stability from long-term stability point of view, the non-conductiveness, it is immune to electromagnetic and radioactive radio frequency interferences. Another advantage of fiber optic sensor is flexibility, that is multiplexing and distributed sensing system, and it is very convenient in deployment in terms of due to its light, smaller diameter, and non-corrosive in nature. So it is very important that to understand how the fiber optic sensors work. So basically, the light beam is sent down on a optical fiber towards the gauge length. Gauge length is first of all fixed. The light wave measures the change in the state, and the change is reflected in terms of light waves is correlated with the strain reading, and demodulation unit which calculates the strains from light signals and gives voltage, and the data acquisition system basically converts this voltage to strains for data processing, which ultimately leads you for arriving at the information for further diagnosis. So this fiber optic sensors typically comprise of following components. Typically, it is comprised of outer jacket, then which is and in the outer jacket and inner jacket, which is basically composed in the armite reinforcing fibers. Then it is provided with the fiber buffer, and inside that you are provided with the fiber sensors, which basically responsible to transmit your data. So this all shielding is provided from abrasion point of view, from weathering effect protection point of view, and from moisture point of view. So why sensor this type of technology is very good candidate for SHM in buildings is because of its bondability, weldability, and embeddability. It can be embedded within the concrete, or it can be mounted on the surface as well of the structural systems. So there are different type of fiber optic sensors classes, that is the fiber Brad grating, long gauges sensors, fiber Perrot gauges, and Brilonic scattering sensors. So if you so these are the I don't want to go into much details about the sensors technology. First of all, I want to give importance on multiplex sensing. So in this technique, a large network of sensors is integrated by a single sensor reading devices. Means single sensor is provided, and wherein you can attach large number of sensors. So in one wire, you can have multiple, or in terms of thousands of system gauges you can put it and capture the data. So that is the biggest advantage of multiplex sensors, which is ideally adopted in buildings. So several sensors are distributed along the single optical fibers. So this can be in the form of a series or parallel multiplex system point of view. So as I mentioned again, there are other different type of sensors that load, displacement, acceleration, temperature, and strain gauges. So now how I should decide that to what extent I should capture the data. So in terms of time, it can be a periodic monitoring, means after a regular interval, I want to capture the data, or on a regular or continuous monitoring I should do. The manner in which the response is invoked in the structure is also very, very much important. So it could be due to the ambient vibrations, or when you are conducting a force vibration study, so dynamic loads which can be generated in the building, or by means of a static load. So static, dynamic, and ambient vibration studies could be performed for testing the structures or capturing the data. So static field testing, if we deal into in terms of static test, we have three tests. So let us focus on the static load test. So in static field test, one has to loads are provided on the structure slowly, and on a sustained loading, the structural behavior or changes in the structural characteristics are recorded in terms of its behavior for analysis and diagnosis about the structural performance. So behavior test, in that objective is to study the mechanics of structures and verify the methods of the analysis. So here you are loading the structures lesser than the maximum serviceable load, which is expected or intended in that particular systems. Another is the diagnostic test, which basically objective is to determine the interaction between various components of the structures. Means we have to we need to create the understanding that how they help or hinder each other. So method of behavior test is very important, and for that purpose, another test procedure which can be applied as a static field testing is the proof test. Here, we are inducing the proof loads to the structure and to assess the load carrying capacity of the structures. So increase the load until the linear elastic limit is reached. So basically, the outcome of this particular test is the maximum load the structure has to withstand without suffering damage. So, but while performing this particular test, you have to be very extra careful that it should not put the adverse effect to the structure systems. So dynamic field testing can also be performed typically for suppose for the moving loads. So for that purpose, stress history test, dynamic amplification test, ambient test, or pull-out test are performed. So stress history data, in that basically the structure is loaded and susceptible to fatigue load, and acquire the data and capture the data and for the further analysis purpose. In case of dynamic amplification tests, the structural design is generally assumes that loads are statics, and this is not always the case, particularly for the bridges is concerned. And for that purpose, you have to sometimes apply the moving loads on the bridges. Third test, which is the ambient vibration test, which is very, very fast and less time consuming and less harmful to the structures, in which you record the structural behavior when it is subjected to ambient conditions like wind, human activity, or traffic. The change in the structural characteristics are recorded by the sensors, and the data acquired from the sensors are further analyzed from different point of view. Alternatively, if you do not want to perform such tests, can be performed on a periodic basis, maybe weekly, monthly, or in years or so. Alternatively, it can be monitored continuously. So it again depends upon the objective and the test for which you are conducting the so based on these aspects, The SHM system design comprise of this definition, basically what is the structure, what is the objective, what type of monitoring you are doing, what type of sensors you are placing, and to what extent the structure is under deterioration stage, and what is the durability and lifespan you want to monitor. So, and for that purpose, one has to what are the steps. Second step is what are the installation issues. So while you are doing the installation of any sensors, the implementing agency should be competent in placement of the data, placement of the sensors, identification of the sensors, its location, and during the construction, it should not be damaged. So this kind of a careful activities should be done in the system design. Once the structure is sensors are installed and structure is put to use, then you have to decide how the dissemination of whatever the data you are getting, how you are analyzing it in an appropriate manner, and then how you are putting it in the public domain. So with this basic background, so now it is very clear that the SHM technology is an ideal technology, which is promising technology for the future for structural infrastructure is concerned. And for that purpose, we have to make use of smart and live structures. And if it is done properly, so it is a good substitute for conventional non-destructive test and all. So now I will come to the live examples. So this is the examples which clearly shows the why we want to go for the wireless sensors, because the wired sensors are creating such kind of adverse impact on aesthetics on the building, and it will cost so much. And if something goes wrong, then it is very difficult to correct it also. So this is the basic object advantage in instrumenting the through wired sensors. Now this is very good that we have a lot of data, but that data need to be analyzed by different techniques. So there are over the years there are different techniques which are evolved. First of all, the change in the mode shape, curvature damage, change in the curvature, change in the frequency, and then in the recent past the CDF curvature damage factor and wavelet transformation. So these are the techniques which has been evolved over the time and which are more efficient in not only detecting but identification of location and extent of the damage. But all these techniques have been evolved after conducting several experimental activities. So when you are conducting the test, when it is subjected to ambient vibration test, not an issue. But for tall structures, if or wherever the ambient data is not adequate, you have to conduct the certain dynamic test by making use of long stroke shakers, which can be vibrated at various frequency levels, but at a very low load. So it will not impact adversely on the structural characteristics, but it will provide you a very valuable and meaningful information about the structural characteristics, and which the data which is generated by placement of sensors at various locations can be analyzed by using different techniques, as I mentioned you, for identification of damage, location of the damage, and extent of the damage. So such techniques have been evolved and evaluated by us at lab as well as at the field level also, by changing the mass or changing the stiffness. So because the damage which is occurring in the structural system could be because due to these main two reasons. And for that purpose, different methodologies have been adopted, approaches have been adopted. And as a result, the data which we got, we have analyzed by different by using different techniques. That is change in mode shape, change in frequencies, change in curvature damage factors, and lastly with the wavelet transformation techniques. So after comparison of the data from using various techniques, it was observed that the Wavelet transformation techniques is an ideal candidate when it is deployed on any tall structures or civil engineering structures for structural health monitoring. So this is the approach which is normally adopted when you are dealing with the model curvature or curvature damage factor technique. Or so in this particular experimental work, we have attempted to change the mass at different locations of the floor, as well as change in the stiffness by cutting the bracings or structural element incrementally and recording the data and comparing the change in the fundamental change in the dynamic characteristics of the structures. So this is how the experimental protocol was adopted in a 8-story steel structure as well as on a scaled down model of 6-story RCC buildings. After conducting the tests under force vibration condition and ambient vibration conditions, the data was captured, analyzed using wavelet transform coefficient techniques, and which clearly shows that the wavelet transformation techniques is very sensitive in terms of identification of the damage at different locations, and it clearly tells you the extent of damage. That is very, very important. So the techniques which I have mentioned earlier, which are unable to tell you about the extent of the damage and location of the damage, but wavelet transformation technique is reaching to the level 4, as I have mentioned you this different levels of SHM. So in conclusion, I should say we have wireless sensors are more prone to the noise than the wired sensors. They have their own limitations when it is concerned in terms of buildings or structural systems. But for example, in bridges, wired sensors can be adopted, but in buildings, we have to adopt wireless sensors. And for the effective functioning of the wireless sensors, we need to deploy more number of routers so that the data interferences, noise interference will not happen. Next important thing is the sensors placement in different locations, particularly the critical locations of the structures is very, very important aspects. And engineer has to be very competent in deciding the locations and placement of the deciding which type of sensors I should put at different locations. So higher damage is more probable to be detected, but the CDF curvature damage factor techniques is basically effective, and but mandatory for that is baseline data or is essential. Whereas in the wavelet transformation techniques, you doesn't need baseline data. So this is the biggest advantage of deployment of wavelet transformation technique. Only thing is that the computationally it is little bit expensive because you need to handle large amount of data and complexity in the calculation computation process. And these conclusions we arrived at after conducting extensive experimental work on the buildings. So which clearly shows that the CDF approach was sensitive to the change in the mass variation to the tune of around 3%, whereas the wavelet transformation techniques is very effective, at least, and it is more sensitive to the total mass, which is to the tune of around 0.93%. So appropriate selection of wavelet is also very, very important because there is a large number of library. So CUG3 type of wavelet means the second order complex frequency BSP line wavelet proved to be more accurate in detecting the damage locations as compared to the complex Gaussian wavelets. So now, after conducting extensive experimental work in the lab and on its prototype, we have deployed this particular mechanism successfully in the new Parliament building of India, so, as well as at the one of the bridge in Mumbai. And the data what we are capturing from this, so they are very sensitive and which is being monitored periodically, and wherein we have put the threshold also. So in case of some abnormal activities by any of the structural element, the data will provide prompts the engineer for any eventualities, and whenever we will get such kind of alerts, so that particular element will be inspected in critical from critical or sensitivity point of view, and appropriately it can be retrofitted or strengthened, or whatever the defect is there, that can be addressed. So this is the big so in conclusion, I should say the structural health monitoring systems using advanced sensor technology and advanced data acquisition and communication systems and data analysis and processing systems will lead to civil engineering into a new era, which will ultimately provide longevity and longer service life with at a minimum cost of maintenance, and it is a promising technology in civil engineering domain. So thank you, friends, for joining the presentations. Thanks for your patience hearing, and I am thankful to ISTAT for giving me an opportunity to speak on this particular subject. So thank you so much. If you have any questions, I'll
Before we allow the people to question, I have 2-3 things. Can I ask, Professor?
Yeah. Yes, sir.
See, you have put sensors. What about the foundation? What type of sensors that do we need? Because structure means foundation and superstructure. So, building, what type of sensors that you will recommend in the foundation? That is one.
Yeah. First of all, sir, I will. Your question is very pertinent, Dhawan sir. If it is a foundation system, so we have to decide again in a very logical way. So if it is a new structures, it is very good that we can put a corrosion sensors, load sensors in the foundation systems at the time of construction. But once the structure is correct, already constructed, thereafter, if still we need, then we need to evaluate the structural systems. So sensors are there, where to place it, and what is the objectivity of placement, and your interest objective function. You have to define your objective functions. For foundation, suppose the weathering effect or corrosion problem is there, and another point is the settlement. Another thing is corrosion or corrosion problem of a reinforcement. So for that purpose, we can place the corrosion reinforcement in the rebars. For understanding the load carrying capacity, we can place the load cells, or you can place some strain gauge based transducers, maybe at the time of construction, or later again you have to dig it out and expose that particular reinforcement or the structural element and place the sensors. So this is how you have to decide subjectively.
The second question, because you are recently involved in the new parliament building. See, the life of is said that it would be, say, 120 years or 150 years. You have already put the sensors and you will be, passing the data and getting the results. See, for my question is for 120 years, what is the mechanism that this continuous monitoring will be assured?
Yeah, you see, this all the sensors are having certain service life or shelf life.
Right.
So sensors, what we are which are available in the market and we're deploying, so they have service life around 50 years or 60 years. So definitely after 50 to 60 years, you have to again check the performance of system. In fact, the performance of these sensors need to be evaluated, or their condition need to be evaluated from time to time periodically, maybe 2 year, 3 year. And you have to capture the data. If it is not functioning properly, you have to replace it also. But yes, you are you are perfectly correct, sir. Because of advancement of knowledge and sensor technology, the sensors which I am deploying today may not be sufficient, or for that technology may be obsolete, maybe 10 years down the line. So in that case, I can replace that particular sensors if needed, and I can put the latest sensors. But and I have to upgrade my entire SHM design systems slowly, so that it will capture the data correctly during the service life of structure.
Thank you. Now, Vikas, please, ask the questions.
Yes, sir. Yes, sir. There are few questions in the question answer box. The first question was from Satish Kumar Sharma ji. What is the extent of utilization of the intelligent SHM system in the country?
Yeah, actually, this is a very good question. Basically, this particular system methodology is itself a new, and in India, this particular SHM in buildings in real life is very new phenomena, and very few structures it has been adopted. But if you look into the Taiwan or other countries, so there it is mandatory that all the tall structures should be instrumented and monitored from structural health monitoring point of view. So their bylaws are there. So in fact, in our country, such bylaws are not there. But yes, again, it is left to the to the client whether he is interested or not. But yes, for the tall structures, one should have this kind of a system mandatorily. So now the evolution stage of this particular system is over, and engineers are need to be enlightened, and this kind of system can be put in use at least for the tall structures, maybe 10 years plus floors should be made mandatory. So we need to enforce the law in law.
Yes, sir. Thank you, sir. The another question, Pulkit Velani asked, what are pros and cons of wavelet transform approach over peak picking method or frequency domain decomposition? Can you give some example of the same?
Biggest advantage of the wavelet transform approach with respect to whatever peak to peak method or frequency or mode shape or curvature damage factor method is that it doesn't need the baseline data. And other techniques needs the baseline data. So if you do not have a baseline data, the result what you get, you will get certain result, but the accuracy of the result is questionable. But in fact, when you are using the wavelet transformation techniques, so it doesn't need a baseline data first of all, and the accuracy, and it is more sensitive to identify the location of the damage, extent of the damage. So that is the advantage with this.
Yes, sir. Mr. Venkat Lute asked how to find the deflection of a bridge using strain measurements. Many times, because of inaccessibility, deployment of deflection sensors becomes impossible. Practically, how to find deflection using strain data?
Basically, no, either you have to place that you have to first of all during the inspection for such critical locations, you have to first of all at the time of design stage only, when you are deploying the SHM techniques, you have to identify which are the critical locations and which type of sensors you should go. So if you are very much interested in displacement deformation data, so one should go for a first of all on LVDTs, which will directly give you displacement. Indirectly also, if you want to monitor, so deploy the strain gauge based transducers, then that voltage signals is converted, and then you have to do certain numerical analysis, which will ultimately give you the deformations. So for that purpose, you need to provide number of strain gauges at different locations. So from fixed end to free end, number of sensors you need to provide, strain gauges you need to provide, and then compare it. So change in the strains at different spans will defines your deflection or deformation.
Yes, sir. Mr. Muralidhar asked, what is the reliability level, any type of calibration for these sensors?
Yeah, as I mentioned, we have conducted the full-scale tests on a building in lab, as well as on the 8-story structures, 6-story structures, RCC and steel both. So this, if we talk about wavelet transformation techniques, it is more effective, and it is up to 1% if it means it is sensitive to the tune of around 0.9% to the mass of that particular flow. Whereas the other techniques needs at least change in the mass to the tune of 3 to 4%.
Vikas, any more question? Hello, I think no more questions. So, Professor Dr. Ajay, we are really grateful to you for highlighting the important subject of structural monitoring of buildings using Wavelet transform approach. I'm sure the listeners will get benefit and make use of this technology in their future construction. So on behalf of Indian Association of Structural Engineers and on my personal behalf, I thank you, Dr. Ajay, for educating us and then making this subject aware of this new subject. Thank you once again, Dr. Ajay.
Thank you so much, sir. Thank you so much to all the participants for patience hearing, and ISTRET for giving me an opportunity, and to you, sir, for very nicely conducting the sessions. And also Vikasji, as usual, is very prompt in conducting all such sessions from time to time. So thank you to everyone from my side. Thank you.
So thank you everybody.
Thank you, sir.